So they don't have things like monads and all that. They try to like keep it beginner friendly.
Do you even Haskell, bro?
From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker.
And I'm Kaushik Gopal.
Welcome to the show. This episode of Fragmented has been brought to you by Rollbar. With Rollbar, you can catch code errors before your users do, because I don't know about you, but the last place I want to find an error is inside of a 1-star review on Google Play. That's just pretty much the worst case scenario, because getting those 1-star reviews to go away is really problematic. So the next best thing is actually preventing them from happening. So if we can prevent those errors, even better. Rollbar will help you do that. The cool thing about Rollbar is they work with all your existing major languages and frameworks. And to really tie this together is they work with your Android application, so they're bug and crash reporting, all that kind of good stuff. And they can also do this on the server as well. And then you can tie that together. So knowing this release X of the Android app and release Y of your Rails API, this perfect storm is happening and you're getting these errors. It's easy to track those things, much easier than it would traditionally be if you didn't have a solution like Rollbar. The cool thing is they also integrate with existing things like Slack. So when I do a deployment or have an issue that comes in, it automatically notifies me inside of a Slack channel, which makes it really easy for me to see what's going on. Especially if there's something that's really high priority, I'll know immediately because I'll be getting a bunch of alerts and it's time to go fix it and check it out. Rollbar is used by a bunch of companies. Kaushik uses them, I use them, but there's also folks like Heroku, Twilio, Kayak, Zendesk, Twitch. The list goes really on and on and on. Now, if you'd like to check out Rollbar, you can go to rollbar.com/fragmented and you'll get the Bootstrap plan for free. Again, go ahead and check that out at rollbar.com/fragmented and you'll get that Bootstrap plan for free. Thanks for listening, and thanks, Rollbar. Today we talk with Anup Cowkur about functional programming and how it applies to Android developers and Android development in general. We dive deep into the various different functional programming paradigms and how they apply and how you can apply them to your day-to-day development. We'll also talk about what it means to be functional and how you can kind of wrap your head around functional programming when juxtaposed against your traditional procedural/imperative programming style that you're probably used to. This is a good conversation and a good introduction to functional programming. We do hope you enjoy it. Kaushik, I've been developing software for over 15 years now, and it's after you've been in it this long, you start to see history kind of start repeating itself, and I've seen it happen with test-driven development and agile methodologies, and there's another one I'm seeing that's popping up once yet again, and that is functional programming. Have you done anything with functional programming, or are you familiar with it at all?
Functional programming. I actually love the concept of functional programming. Now, I haven't necessarily worked with a pure functional programming language. I have been looking at this one recently called Elm, E-L-M.
Mm-hmm. Yep.
It's interesting. It uses a lot of like the functional programming concepts. But I mean, to be quite honest, I haven't dove in all in and worked with a pure functional programming language yet. It is very interesting. The concepts are, and I've been going back and reading up on like the history because, like you said, the concept has been present for time immemorial, right? And I think it has gained way more prominence now with RxJava because of like the style. So it would be interesting to actually talk to someone about this, right?
Definitely. Yeah. And we started digging around, seeing if we could find someone that started talking about it. And there's actually a gentleman that we're going to have on the show by the name of Anup Cowkur. And he has written some very good Android articles on functional programming for Android developers. And so with that, welcome to the show, Anup.
Hey guys, how you doing?
We are doing good.
Doing fantastic. But even better though that we're here talking to you today, because functional programming is some of the things or something that's very popular nowadays, as Kaushik said, when you start talking around the realm of RxJava or anything else like that. So I think it might be key to understand what is functional programming is the first thing. But before we even get into that, Could you explain maybe who you are and kind of your background in software and how you kind of got started in Android?
Sure. So I've been doing Android for like about 6-7 years now, and basically started out at an agency because I was in a sad job where it was like a have you guys ever heard of ETL? It's like extract transform.
Yes.
Like, it's really annoying. That's what I used to do. So then I got this Android book because I wanted to do anything else at all, and then started reading it at night. Made some app, showed it to this company, and then they were gracious enough to give me a job. So yeah, so it's been 6-7 years now. Then I worked at a couple of nice companies. DeviantArt was one of my favorites. Did a short stint at Lisp as well. Yeah, and today I work at Gojek. It's sort of like Uber in Indonesia, and it's huge there. So yeah, that's what I do. And then I'm a GDE like Kaushik.
And Don and many other people, yeah.
he's smarter than I am.
I don't know about that,
but and I sometimes I write articles and things on Medium or whatever is the new trend now.
But you do have like a post now, and we'll make sure to like add that. But can you, before we even start, can you tell us like how you actually got started with functional programming per se? Like, because this isn't something that exists in Android, at least today in the current form, right? So what got you started on functional programming?
Yeah.
Like, there wasn't one specific moment, so to speak. Mm-hmm. But over time, I started realizing that, like, if you have like a method in Java, like in big code bases, when you look at the code, the only guarantee you have about what it's doing is the name of the method or something like that. So it's completely based on humans, right? You go through many code bases where the method name says one thing, it does completely something else. The type system isn't strong enough to tell you exactly what's happening. And then I started like digging into like what do others, is there anything else, right? Like, so that's how everybody starts, I guess. Like, is there anything else out there? Because if all you know is Java, maybe like C or C++, get curious. Then I ran into like Haskell, which is which was like, what the hell is this? because it was much less to do with programming than with math, right? It's intimidating. It's really intimidating when you get into it as a beginner. But somehow I slogged through like the first 3 or 4 chapters of some book I found, and there's this moment you hit when you see that, oh, we can do it like this too. It's very different from the way you think about programs. You gotta sort of like turn your head upside down to like see it. But yeah, like it's basically that. It's just that the main thing was curiosity about like what other paradigms can be used to write programs.
So you bring up something very interesting here, is that you had to kind of flip your head upside down to understand functional programming. And I think a lot of people have felt that way with RxJava when they first start working with it. They kind of realize after they see the power of it, like, oh, I have to think a little bit differently. But I think even before we can even start talking about some of those concepts, I think it's important to cover what is functional programming and kind of base it upon what we do now, which would be imperative or procedural programming. Would you mind explaining like what is functional programming, kind of juxtaposed against how we do things now?
Sure. So idea behind functional programming is to operate at a higher level of abstraction than we write normal programming in. So like imagine if we could, like it's similar to doing like algebra in school, right? You write functions, and then as long as your functions are correct, you can prove that your theorem or whatever is correct. You can get a result from it. And you never think about how it's going to actually run on a machine, right? You don't think about how it's going to, like, if I gave you a mathematical equation and I gave you a scientific calculator, you would type in the equations there, and then you get the result, provided your equation is correct. You're not really thinking about, is there some variable that's going to store it in some RAM or whatever? You don't need to know all that. So the idea of functional programming was to have a one-to-one relationship as much as possible between like thinking about math, thinking like in a mathematical fashion, and then executing code. And that's the fundamental idea behind it. It sounds really like hand wavy right now, but like if we talk a little bit more.
The thing that always comes up in my head is with math functions, right? Like when you see any movies where they're trying to like show like, an Albert Einstein kind of character or someone who's really doing some hardcore math, they always show this like f of x is equal to blah, 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 like, and this is basically it, right? Like when they mean functions and when you mean functions in pure math, it's essentially, how you see those f of x is equal to g or like, or like whatever the function is, like applying that function will always yield the exact same result.
Yeah, exactly. The idea is to kind of get a mathematical reasoning behind writing programs. So if I were to give you a piece of Java code and I ask you to tell you if it's correct, the only way you can actually do it is to probably run through it in your head. Right? But if I were to give you a math equation and it would always follow a certain set of rules, and if you know what rules they are, like you can probably look at it and go, oh, here's this can't be possible.
Right. Based on whether it follows the same set of rules as defined in that function.
Yeah.
So at least for me, the thing that got me started with functional, like at least even interested in that realm specifically for Android development was obviously RxJava. And I remember in the early days, RxJava was called a functional reactive programming language. And then there were people like, the neckbeards, they were like, oh my God, like, no, RxJava is not a functional language, blah, 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 blah. And I do today understand where they're coming from and some of the nuances and the differences, right? But can you help tell our listeners basically how RxJava is similar to functional programming and also why it isn't necessarily pure functional programming?
Sure. So if you want to do pure functional programming, right? So they have these very strict rules, some of them. Some of them like you can't mutate state unless you wrap it around some kind of, they call them monads, right?
Oh boy, monads.
Yeah.
That
Yeah.
scary word.
It's a popular joke, right? Like nobody can explain what a monad is.
It's funny. I was reading one of these resources where they talk about monads and it was said very well. They're like, monads are actually very easy to use. The problem is it's very hard to explain what a monad is, right? It becomes second nature once you start using. It's like the color red or blue, right?
Exactly.
Can you define what blue is? Like, no, I can't. I mean, I would have a hard time defining what it is, but I know what it is. Like, and eventually it's just as you practice it, they say you sort of like understand. And
So I feel like RxJava is like a pretty good approximation. So the reactive extensions was built for to emulate some of the ideas from functional programming, right? I believe that's how it came out from Netflix. And Java community adopted it, and now we have RxJava. And it's so the idea is when you look at RxJava, right, you have chains, right? And you have a chain of operations, and you want your data to be flowing through that. So you're thinking in terms of data flow, right, rather than in terms of objects,
right?
So that's the first difference. Yeah.
Okay.
So and then you're thinking like, okay, here's the one endpoint of my system, which can be the network or the user interaction, right? Let's say. And the other endpoint of your system can be a database, or it can be, again, the screen, right? And what it forces you to do, RxJava forces you to do, is you think about, like, okay, here's the input, and then all the things that happen in the middle, and then I get my output. And how can I model this so that it's easy to understand, right? So you end up making these chains, and functional programming is very similar in that respect to RxJava.
If I'm getting this right, the similarities are in I mean, obviously with the imperative. So imperative programming is essentially like procedural programming, right? So it's like step A, step B, step C, step D, and this is how we traditionally think of programming. What you're saying is it's similar. RxJava is similar to functional programming in that it isn't necessarily step A, B, C because of the asynchronous nature. And like you put it pretty well. Like it's where you have like these chains or like these, which are basically functions, right? And with functions, there's an input and there's an output. And it's very similar to RxJava, right? Like in that sense.
Yeah.
So where it's different, there are these, and again, we're going to probably get into these things called like side effects. But essentially RxJava has no limitations there from what I understand. Right?
Yeah. So because RxJava is built on Java, right? It can give you a paradigm to work with, but it can't prevent you from shooting yourself in the foot. So it can say, okay, here's a map function. For example, let's take the map operator, right? So in a map operator, you're supposed to get list or something or whatever. You get some data. You want to transform it into like another list or another piece of data.
Right.
Now, what if you change that data? Like, what if you mutate the data itself? What if you set the list to null? Right? There's nothing it can do to stop you. What if you, in the map function, write to a database or make another network call or throw an exception? There is absolutely nothing that the language can do, and hence RxJava can do to stop you, because it's not designed to be that. So that's where the differences come in.
Sorry, just to clarify, functional programming languages don't allow you to do that, right?
So there's like a whole spectrum of functional programming languages. So,
Got it,
yeah, but some are more strict and some are like more loose with it. But like if you talk about pure functional programming languages, they're going to have very strict rules about, you know, what kind of data can interact with what other data, how you mutate state. Those are going to be very strict.
So this is really has my mind churning, and it makes me think of some of the listeners that are probably sitting in their car or washing dishes or whatever. And they're thinking to themselves, like, okay, I write programs already. Everything works fine in this procedural fashion. Why should I even think about going functional? Perhaps these are folks that haven't read your blog post or anything of that nature. What's the main draw for wanting to go functional? Why would someone want to consider it or even think about it?
Yeah, why bother, right?
One idea I really like is composability, right? So if you're writing like procedural code, you can look like, let's say you write a whole, like, I don't know, a 20-step operation or something that you want to do something. Then maybe in another function, right, you want to do the first 5 steps, but then you don't want to do the 15 other steps. You want to do something else instead of those 15 steps. Now, there's no nice paradigm for you to take that first 5 and connect it, like keep it the same, but then connect the rest of it. Sure, you can make functions and stuff like that. But when you look at an RxJava chain, for example, which has maybe a long chain, maybe it's 10 operations, I can split the chain at any part that I want and then connect it to something else, right? So it plays together very nicely. Like if all your code is returning observables, and only at the end when like the output is absolutely needed do you join them together in some fashion to get new data, your code becomes very easy to split. That's one of the main draws for me. But that's in terms of like how you write code. Another thing is, if you have functional programming is getting popular these days because you're gonna if in pure functional languages at least, since there's no state mutation allowed unless you're explicit about it, the compiler is a lot smarter. So it can say that it can look at your code and go, hey, look, there's no state mutation. It's a pure function, right? So we can make it concurrent. And that gives you like massive flexibility to run on as many cores as you can, right? I think the main reason the popularity is rising is because of concurrency. Because Moore's law doesn't, like, it's been going down in recent years, right? Your processors aren't getting as fast as they used to. So you're going to have to like distributed work.
Yeah. And I mean, for listeners who are like curious, like in RxJava, there's a scheduler called computation, right? Approach with caution, but basically the idea with computation is it'll automatically expand to the number of cores per your machine, right? Look at the documentation for better understanding, but basically that's what the computation scheduler does in RxJava. So it does try to take advantage of this point that we're trying to make.
Exactly.
So functional programming is still, I don't know, sometimes I feel like I get it, sometimes I don't. Is there maybe do you have any tips for anybody out there that's looking to make that transition, that wants to learn more about it? Is there a way to start thinking more functional? Or maybe even like a functional programming gateway drug that you can think of that could suck us in? And maybe those are your blog posts. I don't know. What's maybe the best way that someone could really start diving into to start understanding some of the topics we're about to discuss?
Yeah, sure. So I would say RxJava is the best gateway drug that we have as Android developers, right?
Okay.
Because it's already there. We just have to stop manipulating state inside the operators, right? A lot of people don't know this. Like a lot of people, even I've met people who use RxJava, right? So there are these specific like section of, if you read the Rx docs, they have this section called like side effect operators.
Oh, yeah. Mm-hmm.
Like do on next and
do on next, do on error, do on terminate, like all these are side effect functions, right?
So they're giving you this, and if you see those do on next and see these things, they're giving you an out of the chain. Like that's the idea. So you want to do something that's not part of the chain. Like you want to write to a database, or you want to update the UI or something like that.
Right.
That in itself, if you just get started with that in the beginning, saying like, okay, I'm not going to manipulate state in my operators, except if they have like a do on next, right? If it's one of the side effects, that's where I'll do side effects, right?
Interesting.
Yeah, so that's how I got started actually. So I started looking into that. Another thing, if you're into JavaScript at all, JavaScript is so flexible that you can write functional or whatever. That flexibility comes at a cost, as we all know. But you can experiment with both styles if you're into web development or something. Personally, I found Elixir, which is a new language, to be really nice, especially for like people who used to like Ruby or Rails. Yep. I think Don did a lot of. Did you do Rails, Don?
Yeah, we both did. Yeah.
Oh, cool.
Yeah, I still do.
So I've been doing some Elixir for some backend work, and it's beautiful. It's not as academic as some of the other functional languages can be. So you can get started without knowing all the names of things.
Got it.
So they don't have things like monads and all that. They try to like keep it beginner friendly.
Do you even Haskell, bro?
So yeah, Elixir would be a good choice if you're like a Ruby person.
Sweet.
Awesome.
I want to step back just a quick moment to what you said about side effects and like RxJava, right? Like with the do on next thing. So if I think about the way I program, right? Like I use do on next pretty liberally in some cases when I want to have like a spinner show up or something, right? Like, or like do on terminate when I have like my network operation is done and I want my spinner to go away.
Yep.
These are side effects, and like the tone that I get usually from functional programming is side effects are wrong, but I need to do these, right? So like it is, so like, what do I do about this? Like, are you saying it's incorrect to even like do these side effects? Like how do I like, relate to that?
Yeah. So it's, so if a program did no side effects, I think it'd be pretty useless program, right? If I'm asking it to calculate something, it has to show it to me somehow. It has to write it somewhere or store it somewhere. So that's a side effect. So you need side effects.
Even presenting to the UI is a side effect if you think about it. Right?
Exactly. Yeah. If you change anything, it's a side effect. Right. So the idea is not to eliminate side effects, but to isolate them.
Oh, that's interesting.
That's if we take away nothing from functional programming except this one idea that we will isolate state manipulation into a certain section of the code, and then the rest of the code will be like no state manipulation, right? If we could take that away, that would solve a lot of our problems already. Because when you see like hairy, messy code, it's hairy and messy because it's manipulating state all over the place. There's like 500 booleans somewhere in the activity, and then they're being set at random times, and you're like, how do I like fit this into my head, right? That's the problem.
How does this even run?
Yeah. And if you touch it becomes a house of cards. Like you change one boolean somewhere, and then it all falls apart, right?
Yeah.
So the idea is to make the functions small, right, and make all state manipulation in one place, and connect the functions together in chains. So it's easier to fit into your head. Also, you can be pretty sure that if you see this, if you're looking at a particular section of the chain, that chain is not going to change anything outside of itself.
Got it. I like that idea where you say it isn't necessarily about avoiding side effects; it's about isolating side effects. I like that concept.
Yeah, one of the early folks I worked with in my career, one of his tips he always used for actually fixing parts of code that were broken were just completely remove any of the side effects that are possible. So if you have a field, if you can put that field as a local variable, put that local. Don't allow it to be manipulated somewhere else. Don't allow it to change. And so this seems to follow a lot of that same approach. How can we eliminate all the side effects as possible?
Yeah, to add to that, another sort of tip you get in functional programming is like derive everything you can derive instead of storing it as so let's say if you have some business logic, right? Did the user get a discount, right? If you can store this as a boolean somewhere, or you could derive it from some other thing you're already storing on the fly, right?
Interesting. Okay, so you mean by virtue of the output that comes out of this function, you can derive that information anyway, so you don't need to store it.
Maybe you have a price class or something. From that class, you can probably calculate like did the user get a discount or not, right?
Oh, you can actually load it into another function, give that as the input, and that will give you the answer to whether you need.
Right. So you just saved yourself one boolean, but a boolean can have two states, right? And so let's say your program has 1 million states now. It would have been 2 million states when you multiply it by 2, right? So you just save that much with one boolean, right? So that's really powerful. Like derive everything you can derive.
So we're talking about side effects, right? And why it isn't necessarily good, and then why RxJava sometimes allows you to do side effects. So, and by and large, we've been talking about like functional programming. Can we drop into what pure functional programming is, right? Like, where does the purity come from? Like, what do you mean by pure functional programming?
When people say pure functional programming, like what they're talking about is like mathematical purity, right? What that means is like a function you have in an imperative language is not the same as a mathematical function.
Right.
We can do whatever we want in this function, right?
You mean like a procedure kind of function that we write as programs?
Exactly. Okay. So it does not, we can have functions that do not give an output, right? Mathematical functions always give an output. Otherwise, there's no point in having them, right? So that's what they're talking about in terms of purity, right? So pure functions will, first of all, not manipulate state. So that's the first idea. And another thing is, if you give it the same input, it will always give you the same output.
Got it. Okay. So it's like a sort of reliable mechanism that whenever you provide input, you're not expecting anything to happen outside of the world of this function, and nothing from outside of the world of the function can influence the output inside this function. So it goes both ways, right?
Yeah. So you can illustrate with a simple example. Like if there's a mathematical function that says f of x is x squared, no matter how many times I call it with the number 3, it's always going to give me 9.
Got it. Yeah. Your x is not changing outside or inside of the...
Exactly.
It's not changing outside.
But in imperative code, I can write the function, but I can do whatever I want. I might not get the same result back.
Got it. Okay, so that's pure functions. So I understand where the purity comes from. We've talked, I think, at this point, like in enough length about why side effects and how side effects play into this. Then we come to this thing called immutability, right? Which is like considered like this virtuous thing in general, like not even outside of like pure functional programming. Like people talk about immutability as being a virtuous concept, right? Can you tell us like how this plays in?
Sure. So immutability also extends from purity. Like, so if I have a function and every time, and I'm passing in a list, right? Now, if I were to manipulate that list inside the function, then I've just created a side effect.
Got it.
So, but if I manipulate the list every time I get a new list, then I cannot create a side effect. That's the idea of immutability, is to allow you to write pure functions, is to allow you to make more pure operations.
This is where I feel like everyone kind of gets confused of like, okay, I'm not allowed to change things. So how am I able to maybe store state or move things around, make calculations and store those calculations? Where does that go? And how would I do it in a pure functional language or functional implementation?
Yeah, if I can never change anything, like, I mean, what the hell, right?
No, you can't change things.
Okay.
But most of the time when you're changing a list, you're going to get a new list. Maybe you want to replace, so let's say you have like a master list, right? That's your source of truth, right? That could be stored in memory or your database or whatever. Now, when you want to change that list, we use like a mechanism around it. So it's hard, so that there's synchronization around it. That's where you want synchronization, right?
Okay.
You want synchronization around your source of truth, whatever that is. So because if multiple threads are writing to that source of truth, then you want them to do it one by one or whatever strategy you want, right?
Oh.
That's where you need synchronization.
Interesting. So let me just try to confirm my thinking along this. So with the reason immutability is important here is in a way also because, again, this is like the standard threading thing, right? Like if one thread, and I think your blog post actually talks about this like in detail. So we'll make sure to add a link about this, right? The idea is that if you have a thread 1 that pulls a value, it reads a value X, and then comes back and presents the output, right? Before like the operation like happens, if another thread picks up that value or updates that value, you don't want it to change under you. But if it's mutable, it will change. And that's like typically how you run into like gnarly race conditions, right?
Exactly. Yeah. So we're basically just, we're not changing the original value. We're getting a new value for us to use, right? But at the end, it all leads to a side effect, right? So let's think of an Android app, right? You have a screen. Now, let's say the screen is showing a list of items. I run 2 threads and they both do different things to the list, right? But then I have to like synchronize and get them to one list that I display to the user, right? That's where I want to put my synchronization on. That's where we need mutation. So again, it's not that we can never change anything. It's just we change things only when we need to. And when we do change things, we put proper synchronization around it. But it's still a lot easier to follow and read the code because all your synchronization is going to be in like a few places rather than it being everywhere right now.
Makes sense. Okay, yeah, that kind of clears up a lot of questions that I would originally had, because my initial understanding from coming, and this is years ago that I got into some functional stuff, was back then was, okay, I can't have any inputs or outputs that change, and it feels like there's just this big function that I can use for math stuff. And but this makes sense if you're putting some synchronization around various different parts of your application. And again, it's only going to be in a few locations. Then it sounds like something that you could definitely do.
So we talked about immutability, and like the problem with us Android developers is like immutability is costly, right? Because like you're creating like a whole bunch of these objects.
Exactly.
How do like pure functional programming languages handle? Like, is it just that okay, we're running on a server, so we don't care about
memory?
Resources, or memory?
Yeah.
Like how is that dealt with?
So there's they created basically a whole different class of data structures for themselves called persistent data structures, right? So what a persistent data structure does, it does not manipulate the original data structure, but just changes the bit that it needs to change to get you what you want. So sort of think of it like Git, right? You have a whole Git repo, and then you want to make a bunch of changes to it. It's going to store the diff, but not like the whole copy of the repo, right? And then when you ask it for a specific commit, it's just going to apply all the previous commits and get you there.
Right. So it's not really recreating a whole new copy. It's creating a diff.
Right.
So the size is basically just the diff of the...
Yeah. So it lets you pretend that the closer you get to the metal, right, in a computer when you're programming it, the more you have to worry about state.
Right.
What's my register, RAM, all these booleans, God knows what, right?
Yeah.
So this is operating at a higher level of abstraction. The compiler is still doing all that, right? But it's going to let you pretend that you don't have to care about it, and that's great.
Does this change based upon the functional programming language you're using? Does the implementation change, or these type of persistent data structures, how they work?
Yeah. So Haskell has its own. I'm pretty sure everyone has their own. But there's some like for example, a linked list is a linked list, right? So they might have like a persistent linked list. The implementation might be slightly more optimized or whatever, but the ideas kind of carry over. Clojure has its if it is a JVM language, which is a functional JVM language, they have a whole persistent data structure built, which is optimized to run on the JVM. So it's not like you can't do it on Java.
All right, so it's just different. Okay, that makes sense. There's a whole, we could probably literally talk about functional programming for the next couple of hours, but I think it might be really useful to at least cover some of the main paradigms of functional programming. And there's different types of functions and so forth. And there's one known as a first class function, or some people call them first class functions. Can you explain what these are and what value they give us in the functional programming world?
So a first class function is in functional programming, logic is also treated as data. What that means is basically your function is the same as any normal data type that you have, right? So you can you have strings in Java, right? Imagine if function was also just another data type. So you could pass it to other functions. You could assign it to variables. You could do whatever you want with it, right?
Function passing kind of thing.
Yeah, exactly. So what that gives, the flexibility that it gives you is not only can you now pass data around, but you can pass logic around.
Interesting.
This kind of really makes me think of Kotlin a little bit and being able to pass functions around.
So there's you see if there's attempts in OOP to emulate things like these. So, for example, I think it's called strategy pattern or something like that. One of the design patterns, which lets you decide what logic you want to run based on some parameter at runtime.
Got it.
Yeah. So that's basically just you wouldn't need that if you could just pass a function.
Right.
Because the logic is in it.
And those are known as first class functions, correct?
Yeah.
And so how, if as an Android developer, how would I basically think about this from an Android perspective? Is there examples of how I could do this, or how would you approach this from an Android developer perspective?
I mean, are lambdas basically that? Like, I'm getting a little confused now. Like, is like...
Yeah. So first class functions is basically any function you can treat as a data type, right? Okay. Lambdas are also first class functions.
Got it. Okay.
Right? Okay. Yeah. As an Android developer, like the closest thing you have in Java is like anonymous inner classes with one function in it, like on click list.
Okay.
Yeah. So that's, I guess, you have to pass the whole object though, because there's no concept of a function living on its own. But Kotlin has first class functions.
So there's things called first class functions we talked about. There's also something known as higher order functions, which kind of confuses me. I see first class and I see higher order. What's the difference between those two?
So higher order refers to like it's a mathematical concept, because they have like first order functions and higher order functions, and so
this is like the degree. I never thought about this before. Okay.
But honestly, like when you're programming in functional languages, for some people like us who are not neckbeards, we don't have to worry. We don't have to worry about it. You know, we just need to know that first class, higher order, whatever they mean, that you can pass functions around.
Oh, okay.
We have first class functions, higher order functions, and then there's obviously the ones that we talked about called pure functions, right?
Yeah, same input, same output. That's pure functions.
Oh, that's pure functions. Okay, so it doesn't have to do with necessarily the number of inputs and the number, like, and the output that comes out, right?
So I don't exactly know if that's a consideration, but as far as I understand it, it's got to do with, if you give the same input, it has to be the same output. But yeah, if you go into like Lambda Calculus, which, do we want to talk about it? Okay. So
we'll add some links to the show notes on like good notes, because Lambda, I mean, don't get me wrong, I love Lambda. Like the topic is like extremely interesting to me, but I feel like that like takes us like way into the weeds, right? Like at this point, we're just like trying to understand the basics as to like what this like functional programming thing even like means. So
so let's just say that it's a branch of mathematics that tries to model computation, and that's where functional programming, a lot of functional programming is based on it, right? That you have the concept of pure functions, and in pure functions there, they can only take one input, right, at a time.
Got it. Okay.
So every function only has to accept one input as its parameter, right? And it also has to always return the same output for a given input. So that's the definition of pure functions there.
Got it. Okay. That makes sense. Okay, so since we're throwing terms into like, this part, there is this term called closures, right? Like, and closures is like actually more common. Like I would imagine most developers and programmers have heard of closures, right? So, and again, I'm not talking about the programming language called Clojure, which is like Clojure, Jure, I guess. This is just like basic closures, right? So can you tell us what closures are? Closures
are lambdas.
Closures, boom, there we go. See, that's like the kind of definitions I want. Like, done, next. So basic callbacks are also closures?
So if they are encapsulating, if they can capture their environment, they're called closures, right?
Got it. So it's like literally
it's closing,
right?
Yeah, it's closing over the environment. So if it is using a variable from the outside, right?
Got it.
And then I pass it around to other functions. But at the time it captured the variable, it keeps the value of the variable the same for itself.
Got it.
Does that make sense?
That does make sense. So, I mean, it's more to, this is like...
Yeah, okay, so let me just put it in better words for one more time. So if I have a variable, right, and then it has value 1, and then I pass it to a closure, right, at that time it's 1. So the closure is going to store it as 1. And then I pass the closure around to somewhere else. It's always going to be 1, even though I change it to 2 here. So it's closing over the environment. That's why it's sort of called.
Oh, I see. Okay. That makes sense.
So, all right, this makes sense. Now, where does immutable state kind of to fit into all this? I mean, it sounds like, again, we can't really manipulate things unless we're passing around these persistent objects. But is there anything else to think about in regards to immutable state when we're talking about the main paradigms of functional?
Yeah. So when you start functional programming, you're gonna immutable state is one of the fundamentals. You're gonna see it everywhere. Like the idea they're trying to push you to avoid a mutable state unless you can't. So, and even when functional programming allow you to mutate state, they're gonna put like these constructs around it, right? Like some sort of a monad, and but that's to let the compiler know that, hey, this is a dangerous operation here, right? Let's synchronize that part. So the explicitness is the end goal.
Got it.
Yeah, but like you have to think about cost though as an Android developer, right? You know, if you start passing around deep copies of array lists around everywhere, you're quickly gonna run out of memory.
GC thrashing.
So
array list of bitmaps.
But there are some options you can use on Android for immutable collections, which I think we can talk about in a bit.
That makes sense. So since we're still on the topic of like just like the paradigms of like functional programming, right? We typically because you've mentioned the word synchronization and that like sparked this thought in my head. Typically we use like, mutexes and like, the synchronized blocks and like all those like good stuff.
Yeah.
Does that mean with functional programming, you never have to use any of those if you follow like the paradigms of function programming to the T?
You can mostly avoid them. But remember I also mentioned that, at some point, all the streams of data, right, on all your threads has to come together to present something to the user.
That main thread, man. Yeah.
Yeah. And at that point, they all have to be in some sequence or some combination. So you're probably going to need some sort of synchronization there. So those tools that you've invested in all these years, they're still useful.
Got it. Okay.
But they become much simpler because their application is much smaller now. If you decide to do
Got
this.
it. That makes sense.
This has been a super fascinating discussion on functional programming, and I probably feel the same way that many of the listeners do right now. And that is, all right, this sounds cool. It sounds like something I can get a lot of value out of. It sounds like there's something I can even take into other languages and learn from and grow as a developer. But how can I apply this functional programming concepts and everything in my day-to-day development as an Android developer? Is there anything out there that I can use or do that'll help, kind of kick me down that path?
Yeah, I would say get your feet wet with Rx if you haven't already. But I doubt like the listeners of the show are not doing Rx. Maybe you've been doing Rx, maybe you've just been using it for API calls, right? Or maybe you've just been using one or two operators, right? But Rx is a whole world in itself. You start digging into all the operators and what they can do, and if you try to model your business logic in terms of streams, you're going to see a lot of things you can learn about. And like the more you learn Rx, when you do switch into a functional programming language, if you ever do, you're going to feel right at home.
How do you feel about using something like auto value to help, limit mutability? Does that also help kind of send you down the same path too of exposing those types of things?
Sure. Auto value is also so there's Java as well. But we don't use that a lot because it's like the method count is too much, I guess. But auto value is also quite helpful. Like if you want, data types that are just purely data.
Speaking of Java, I think I recently saw that there was a commit on the Java repository where it looks like they're trying to make an Android version. So that should be an interesting thing to watch.
Oh, interesting.
Yeah.
There was another library I found called PCollections.
Yeah, and your blog post talks about this, right? Can you tell us like why I would use this?
So it's sort of like remember I mentioned that Clojure did this whole port of the persistent data structures to the JVM.
Right.
This is something similar. So it has a few. It doesn't have all the data structures, but it has like the basic ones like list and maps and things. And like I haven't used it extensively, but from what I've seen, it does a pretty good job of letting you use immutable collections while they're not really immutable.
Got it. And I guess like the idea is because the problem with Java at least is immutability is not necessarily as straightforward, right? So, for example, and Don's like, I think covered this in like one of our effective Java episodes. Like, in order to make something immutable, you finalize the class so that it's not extendable, and then you you use final variables. Like, you remove the getters and you remove the setters. The problem is, and I think you also mentioned this in your blog post, when you have a getter and you return like a list, like an array list or any object for that matter, that's not a primitive. Typically you can, like, even though you may not necessarily reassign the object, you can still change those values, right? So they're totally still mutable. And I think that's where like the advantage with this thing comes in, right? Like with this PCollection libs, like the lists, like if you have like a data structure that has like a list object or like array list or something, they have versions of the same collections. And I mean like collection as in like a Java collection interface that don't allow you to do these things, right?
Yeah, you're right. So if you use a PCollection list, for example, and you try to remove an element from it, it's just going to give you a new list.
Oh, that's pretty cool. So like it allows, so it's almost like you don't have to worry about it. You just use a list like you're like used to using a list, but underneath the hood, it just swaps it out with the new collection. So it makes it immutable.
They seem to have put a lot of effort into maintaining API compatibility with the Java Collections API.
Oh,
so
nice. Okay. So you can use the same collections.sort, like all your comparators, all that good stuff, all that comes.
Worth trying out at least.
Okay. So PCollections and auto value, like if you're interested in immutability, definitely RxJava. Like people should start using RxJava more. And I mean, we sometimes we take it for granted, saying, "Oh yeah, everyone should be using RxJava," right? Like that's not necessarily the case. I have seen many like very reputed like developers who still don't use RxJava. So RxJava is a good intro, I think, also to functional programming. And we've talked about it. Like if you thought RxJava was difficult, like pure functional programming, try looking at Haskell, right? All that good stuff.
I think one of the other ones too that folks should take a look at if they haven't already is Kotlin. Kotlin kind of puts a lot of this stuff right in the forefront of your day-to-day development, and that's going to be with basic operators like list of, which gives you an immutable list of objects, or map of, give you an immutable map, and then the Kotlin data classes. And there's a whole bunch of stuff in there that in Kotlin that seems to kind of really limit mutability if that's kind of what you're going down. So that can also be another gateway into the functional world, in my opinion. Yeah.
And I mean, if I use Kotlin, how close am I to functional programming?
So Kotlin is beautiful, by the way. We just started using it at like I convince people at work to use it, and just put something out in production and moving more and more towards it. It does a very good job of like combining the two worlds as much as it can be combined. So you have first class functions, you can pass them around. You have very clear type systems that separate between mutable and immutable types, right?
Got it.
That gets you a lot of the way. That gets you I would say like 30 to 50% of the way is that, because in Java, when you have to do this, it's annoying because you have to write these things by yourself and you have to be careful not to violate the rules that you're setting up for yourself, but it's not part of the environment, right? Like in Kotlin, the compiler can tell you, the IDE can tell you. Yeah. So like that's another, like you were talking about gateway drugs, right? Kotlin would be awesome.
Just out of curiosity, right? Are there other pure functional programming languages? We have talked about let's see, Elm is the one that I've tried, which I thought was pretty good. You mentioned Elixir. That's the one that you tried.
Yeah.
Haskell is like a mathematical function. Like Haskell is known to be a beautiful language and pure, but you gotta like be ready to take it on, I suppose, right? Now, what are some other ones?
There's Scala. I don't know if it's called a pure functional language because the idea behind Scala was to meld OOP and functional together. But so you can drop down into OOP whenever you want in Scala, as far as I know how it works.
Okay.
There's Lisp. Lisp is probably the oldest functional programming language in the world.
Yeah.
And there isn't even like one Lisp. There's like a bunch of different implementations of Lisp.
Oh, really?
So there's Scheme, there's Common Lisp. Clojure is a Lisp. Clojure is also a pretty good language to try. If the founder of Clojure, Hickey, he does like the best programming talks, I think.
Oh, really? Interesting.
Yeah. It's very interesting talks. He talks about language design and things like that. He's one of the best speakers, I think, personally. and it's a pretty well, like, I haven't personally tried it, but from what I've read about it, it seems like it's a very well designed language to try. Yeah, but I would recommend, if you want to get started with the real functional programming language, like Elm, like you said, Elm is great, and Elixir would be great if you're more of the back end kind of person.
That makes sense.
Okay, so that kind of covers a ton of information there. We were going to put a bunch of notes inside of a bunch of resources inside of the show notes. We have some links to Anup's blog posts, which is entitled Functional Programming for Android Developers, which is a multi-part series. We'll be throwing some stuff in there, which is around functional programming in JavaScript, blog post by Eric Elliot, and also another podcast from the folks and friends over at the Context Podcast. They did some stuff on functional as well. So we'll throw those in the show notes. So if anyone's interested and really wants to dive a little bit deeper, click the show notes icon inside of your podcast app, or hop over to fragmentedpodcast.com and take a look at the show notes to get those links.
Yeah. And Anup, right now I only see 2 parts. So when are you going to get your act together and get us more parts?
No pressure.
As I always tell my product managers, 1 to 2 weeks.
Oh, the mythical 1 to 2 weeks. That's like
1 to 2
in
weeks.
software engineering terms. Thank you so much, Anup. This was like super helpful. Like, it's just because this is like new concepts that people are slowly starting to warm up to. And it's always nice to have like these introductory sessions where we are sort of trying to like wrap our heads around some of these concepts. So thank you so much for it.
Thanks for having me.
Yeah, thank you.
This was fun.
If folks want to reach out to you and ask maybe some of the other questions that they have, what are some of the best ways they can find your content or can reach out to you?
Yeah, so my name is weird, so I get all the nice handles on the internet. So you can just find me on Twitter with my name. It's at my name, Anup Cowkur. Same on Medium. Yeah, if you want to leave a comment on the blog, if you want to read it, if you won't have any thoughts. But Twitter is probably where I'm most active. You can like text me and whatever.
Don, if folks want to find out all the functional stuff that you're up to,
the best way is to reach me through Twitter at Don Felker. And Kaushik, how do folks get a hold of you to query you for your knowledge base?
I am Kaushik Gopal on Twitter, and our Twitter handle is Fragmented Cast. So if folks have like other suggestions and other stuff that they want to shoot our way, that is usually the best way. Thank you all for listening. We will catch you in the next episode. Thanks again, Anup.
Thanks, Anup.
That's it for the show, folks. Fragmented is hosted by Don Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.
This episode of Fragmented has been brought to you by Rollbar. Now, if you'd like to check out Rollbar, you can go to rollbar.com/fragmented and you'll get the Bootstrap plan for free. Again, go ahead and check that out at rollbar.com/fragmented and you'll get that Bootstrap plan for free. Thanks for listening, and thanks, Rollbar.